AP exam, they don't give you any notes at all. So if the AP exam gave you notes, then maybe we wouldn't need to memorize it, but they don't. They expect you to know these. So let's go through the sum and difference identities. Normally students remember these. So cosine of x plus y, so you have a sum of two angles. Can I just distribute the cosine? Oh, you can, except it's going to be a fatal error. Don't you dare to distribute. Cosine, cosine, what? Plus or minus? Minus sine, sine. That's the sum identity for cosine. And then what would happen if this is a minus? Then that would be a plus. So that's the way we write it. See, the top sign goes with the top sign, the bottom goes with the bottom. You've seen that before, right? Okay, then what about sine? Let's just do this. So we got sine of the first, cosine of the second, plus cosine of the first, sine of the second. And then if this is a minus, that's a minus. And then of course, tangent x plus y, tangent of the first plus tangent of the second, all over 1 minus tangent of the first, tangent of the second. There you go. Oh, and of course, if this is a minus, that's a minus and that's a plus. Okay, so as you're doing the problems, you need to start memorizing these. Is there an app for trig identities? Too bad, they should have one. But they don't. Okay, so did you guys derive these last year? I would like to derive at least one of them for you because it's like I said, we don't have that much time. We even got less time this year, so we're just going to learn how to use them. Okay, so here, compute. Here, this is a typical problem. Let's do cosine. Cosine of 7 pi over 12. Now, is that an angle that I'm supposed to know right away? Well, if you're on the math team, it is. So if you're on the math team, you'll look at that and go, whoo, negative root 6 plus root 2 over 4. Well, nobody on the math team here. Okay, see, we're just trained like that. So what about the regular commoners then? How do you do this? This is a 105-degree angle now. That's like over here. See, in the math team we go, that's a small negative, and then we just write the answer. Okay, so what did you do last year? Well, you got to write 7 pi over 12 as either a sum or a difference of two angles that you know.
3 pi over 12 plus 4.
Okay. So that's the same thing as cosine of 4 pi over 12 plus 3 pi over 12. Of course, that can be reduced to pi over 3 plus pi over 4. And aren't those two angles that you know? So you got to make sure the two angles are angles that you know now. That's not the only way. What's another way you could have done it? 9 pi over 12 minus 2 pi over 12. Yeah, so there's an infinite number of ways of doing it. Just get one of them correct. Okay, now apply the identity. Cosine of the first, cosine of the second, plus or minus? Because that's going to be a fatal error, you know, you get this sign wrong. Minus sine of the first, sine of the second. And then you just got to know your trig values. But we do. Right? So, come on. 1/2 root 2 over 2. Now you got to think, is it better to write root 2 over 2 or 1 over root 2? So you kind of have to look ahead to the next step. What do you think? I don't know, Mr. Park. Well, I already wrote it. Root 2 over 2 is better in this problem. Minus root 3 over 2 times root 2 over 2. Make a least common denominator of 4. Final answer. Root 2 minus root 6 all over 4. Hey, didn't I write it down? Oh, I thought I wrote it down, the answer. Anyway, that's it. Doesn't take that long to do. No, you guys remember doing problems like that last year, right? Okay, what are other problems you can get? Well, what about this? What is the sine 11 pi over 12 cosine of, 5 pi over 12 minus cosine 11 pi over 12 sine of 5 pi over 12. So how would you do this problem? Compute this, and that using this technique and then just simplify it. Yeah, you could, but how long is it going to take you to just do one of these? And then you can do 4 of them? Yeah, you could, but why? You should be looking at this and go, hey, you somebody, huh? Hey, you somebody. I just erased it. Come on, that's why you guys gotta have your identities at your fingertips. Hey, you somebody. This is the identity for, is it sine, cosine, or tangent at least? Sine 11 pi over 12 plus or minus? Minus 5 pi over 12. Yeah, and then, I know how to subtract. What is 11 pi over 12 minus 5 pi over 12? And please don't say 6 pi over 12. Pi over 2, and that's a number I know. We took a speed quiz on it today. 1, boom. That's way faster than computing 4 of those and then simplifying it. That's why you gotta know your identities. It's gotta be part of you. Okay, so you get lots of problems to do like that. Okay, let's do a tangent one. Compute. I don't know why, but students have problems simplifying it the last several years. Compute the tangent of, let me think. What quadrant do you want the angle? Let's just do a first quadrant angle. How about pi over 12? Okay, again, math team people, we just look at that and we know the answer is 2 minus root 3 already. That's because pi over 12 is there, tangent is small and positive. That's the small positive answer. Anyway, but the rest of the commoners, what do we do? We write that as a sum or a difference of 2 angles that we do know. Okay, so 4 pi over 12 minus 3 pi over 12? Or do you want to go 3 pi over 12 minus 2 pi over 12?
That one.
Okay, let's change it then. It doesn't matter. There's an infinite number of ways of doing it. Does that work? Is that equal to 1 pi over 12? All right, so isn't that pi over 4 minus pi over 6? See, there are angles we know. I erased the identity, but you guys are looking at it now, right? The identity sheet is the first sheet on the worksheet. So tangent of the first minus tangent of the second all over 1 plus tangent of the first tangent of the second. You know, after a while, you don't even have to write that stuff down. You can just go tangent pi over 4, just write 1, right? These you can do in your head, right? So what do we got? We got 1 minus, what is tangent pi over 6? 1 over root 3? Okay, now think. Which one would be better? 1 over root 3 or root 3 over 3? Think ahead in the subsequent steps here. Root 3 over 3? Are you sure? Mr. Parker, just don't know. Okay, if you don't know, then just pick one and go with it. Which one are we going to go with? Okay, I heard root 3 over 3. All over 1 plus, what is 1 times root 3 over 3? Root 3 over 3. Mr. Park, can I leave my answer like that? Yeah, you can, but you're going to get points off for not simplifying. Come on, this is like any other math class. All answers must be simplified. Okay, so what should I do to simplify this? Oh, maybe I should have done 1 over root 3 then, huh? Like I said, if you don't know, just pick one and go with it. Would this have been any better? Yeah, because look, how do you simplify this? Multiply top and bottom by root 3. So you get root 3 minus 1 over root 3 plus 1. Is that simplified enough? No, Moose Breath. What do? Come on. Multiply top and bottom by the conjugate of the denominator. Okay, so you multiply out the top, and what do you got? You got 3 minus 2 root 3 plus 1, all over 3 minus 1. What does that come out to? 4 minus 2 root 3, all over 2. Lift and separate 2 minus root 3. Kabam! See, that was the same answer. All right, and then finally, you gotta be able to solve equations using the sum and difference identities. Okay, let me make one. I don't want to make it the same as the homework. Oh, that's a sine one. I'll do a cosine one then. How about this then? Cosine 5x cosine 2x plus sine 5x cosine 2x equal root 2 over 2. How would you solve an equation like this? Mr. Parker, we didn't learn the double and triple angle identities yet. Yeah, that's right, that's tomorrow's lesson. So what do you do? Well, what are we learning this chapter? Hey, you somebody! This is the identity for cosine of 5x minus 2x. And then, of course, that simplifies to 3x. And then now, this is like last night's homework, right? Is this a number I'm supposed to know for cosines? Yes. Cosine of what angle is root 2 over 2? Did you guys practice this thing? It helps, you know. So cosine of what angle is root 2 over 2? Pi over 4, and what's the one down here? 7 pi over 4. Divide each answer by 3, so you get pi over 12. 7 pi over 12. Oh, that was easy, Mr. Park. How come I see a minus 4 on my paper? Because you're missing 4 solutions. Do you guys forget already? What happens if the variable is 3x? What do you have to do? You gotta go 3 times around. You only went 1 time around. So what do? You add 2 pi to each of these. Remember, 1 time around is 2 pi. Add 8 pi over 4. Go. 9 pi over 4. 15 pi over 4. Again, add 8 pi over 4. 17 pi over 4. 23 pi over 4. Now you divide by 3 and you get 3 pi over 4. 5 pi over 4. Don't forget to reduce it. 17 pi over 12. 23 pi over 12. That is super important, you know. You have a 3x, 4x, 5x. You got to go 3, 4, 5 times around. And should I even discuss number 7? You know what? I will. Okay, last example and we're done. Okay, if you know the slope of 2 lines in the Cartesian plane, can you find the angle formed by those lines? And the answer is yes. We use trigonometry. So give me 2 slopes. This line has a slope, and I want to make the same as the homework. So 1/3 and 2. How about 1/2? So the slope of this line is 1/2. And the slope of this line is, give me a number bigger than 1. 3. Is that the same as the whole? No, but it's kind of different. Okay, so good enough. What is the measurement of this angle formed by 2 lines? Now, whenever you find the angle between 2 lines, you give the acute angle. Give the smaller one, okay? So, if you read what it says over there, it says, are you guys reading? To find this angle, first of all, you measure the angle counterclockwise because that's the positive direction in mathematics, right? Just like your trig angles, right? Counterclockwise is the positive direction. The initial slope, the slope of the initial is m1. The slope of the terminal side of the angle is m2. And then you just plug it into that formula right there. Every year I put this problem on the quiz and the test. And I don't know why students just bomb it. So the tangent of the angle is equal to m2 minus m1 all over 1 plus m2 m1. Hey, that formula looks kind of familiar. That looks like the tangent, yeah. In fact, when you do where's the problem? Oh, how come there's no problem there? Well, you know what? Oh no, we did it on, it was on trig, was it on trig 1 or trig 2? The one you had to, that I mentioned the angle of inclination. Does that sound familiar? And what did we learn in that problem? There was a problem, that's an inclination. We're right there's the problem. Okay, here. Okay, put this on the side. We're gonna go back. See, that's why, if you have a question on something, even though I give you all the solutions, ask. It's not that hard to ask, you know. Okay, so here's the positive x-axis. Let's say you have a line. Let's say the inclination is 30 degrees, like that. The inclination of a line is the angle a line makes with the positive x-axis. How do you compute the slope of this line? What did we learn in that problem? Anybody? The tangent. The tangent of 30 degrees is the slope. What is tangent of 30 degrees? Root 3 over 3. 1 over root 3. I don't know which way you want to write it, it doesn't matter to me. How do you get that? Well, okay, what if you didn't know anything? Make a right triangle. In a 30, 60, 90 triangle, if the hypotenuse is 2, what's the short leg? 1, and then what's the long leg? Root 3, so therefore what's the slope? Rise over run. See, 1 over root 3, root 3 over 3. So anytime you have an angle of inclination, the tangent of that angle is the slope. And that makes sense because tangent is opposite over adjacent, which is rise over run, right? So what about, where did this formula come from? That's because, look, where these two lines intersect, I don't want to derive the whole thing, but here's the positive x-axis. Isn't this angle equal to this big angle minus this small angle? Let's call it alpha and beta. So theta is equal to alpha minus beta, tangent both sides. Just like you can natural log both sides, you can e both sides, you can tangent both sides. And then now you can see how they come up with this formula? Yeah, tangent. That's the difference formula for tangent. I don't want to derive the whole thing, I just want to make sure you guys know how to do problems. Okay, so let's get rid of all this other extraneous stuff. The main thing is, so does everybody understand you have to measure the angle counterclockwise now? And then the initial side is M1, the terminal side is M. It's really easy. Plug it into that formula. So tangent theta equals, so what number do I put first? 3 or 1/2?
3.
Okay, good. 3 minus 1/2 over 1 plus 3 times 1/2. Multiply top and bottom by 2. 6 minus 1 over 2 plus 3. Oh, this comes out so nice. Look at that. I didn't plan for it to come out this nice. 5 over 5, which is 1. So if the tangent of this angle is 1, what does that angle have to be? 45 degrees, or pi over 4. I thought it was going to come out to something like 4/5 or something. Then we'd have to use our calculator to get that angle. So if it comes out nice like 1 root 3 or negative root 3 over 3 or something like that, then you can just write down the angle. Otherwise, like the second one, 7b, you're going to have to use your calculator. You guys know how to find the angle? You guys have to do it for physics, right? If you know, okay, for example, if you know the tangent of the angle is, give me a number, 3/4. That's not a number I'm supposed to know for tangent. Can you figure out the angle? What do you punch in on your calculator? Tan inverse 3/4. Or I think on your calculator they have A-tan, yeah? That stands for arc tangent 3/4. But punch it in, and if you're in degree mode, you should get something. Come on, you guys in physics should know this one already. And that's almost everybody here. 36.9 degrees, right? Here, you can impress your physics teacher. Anytime you have, do you guys have 3, 4, 5 triangles quite a bit in physics? What's a triangle? 36, this is of course just rounded to the nearest 10. 36.9 and 53.1. tell me that's the teacher told him to remember that, but, well, I guess if you don't listen to me, why listen to the physics teachers then, right? All right, so tomorrow, I believe, is the last lesson, so we're gonna cover the double and half angle identities. You guys even remember those? Really? Woo! What's gonna happen now, because do you know that now there's no algebra 1A, 1B, 1C starting this year? It's all combined into just algebra 1. There's no 1A, 1B, 1C anymore. And there's not going to be any trigonometry. But I think that's maybe 2 years from now. It's all going to be incorporated into algebra 2. It's going to be called algebra 2 and trigonometry. Because the administration wants more students to get to calculus without having to go to summer school. And that's how you do it. So that's what's going to happen. That's what's coming down the road. All right. You got 7 minutes left. You can know a few problems. Oh, that's a dozen.